Yes, so the question here says the ratio of the radius of gyration or gyration of a thin uniform disk about an axis passing through its center and normal to its plane to the radius of gyration of the disk about its diameter. Okay. So first let's find out the moment of inertia, the moment of inertia of a disk. If this is a disk, it's not a ring, it's a disk. So about this axis, that is perpendicular to the plane, this axis here, about this black axis, if the mass is m and the radius is r, the moment of inertia is mr square upon 2 for the disk, right? And if we have to find the moment of inertia of that same disk about an axis, about an axis, that is the diameter of that one, it is this one, this axis is in the plane of the disk, right? It is in the plane of the disk. So we'll have to use the perpendicular axis theorem. Okay. So that says if this is the z-axis, this is the z-axis, this be the x-axis, and this be the y-axis here. Okay. So see, x and y-axis, they are in the plane of the disk. Z is the axis perpendicular to the disk. Okay. So about z, the moment of inertia is mr square by 2. Okay. The perpendicular axis that we use for laminar bodies, right? For sheet, for thin disc, like this. So we use perpendicular axis theorem for laminar bodies. And it says Iz is equal to Ix plus Iy. Okay. And by symmetry here, for the disc, you can see that the moment of inertia about this x-axis, about this diameter, is going to be the same as this diameter. So Ix is equal to Iy as well, I can say here, right? That means Iz is 2 times Ix is equal to 2 times Iy. Okay. And Iz is what? Iz is this thing, mr square by 2. Okay. About this axis perpendicular to the disk, right? So from there you can say that Ix is equal to Iy is equal to mr square upon 4, right? So about any diameter, the moment of inertia of a disk is mr square by 4, right? This is it. Now, what is the meaning of radius of gyration or gyration? Okay. So the radius of gyration is, for any body, let's say this disk is mr square by 2 about the z axis. Okay. So if someone says what is the radius of gyration, that means if I give you a ring of the same mass, okay, what should be the radius of that ring so as to have the same moment of inertia? Okay. So if I say the radius of gyration for this one here, the moment of inertia for a disk, for a ring is what? Mr square simply, right? So here we have mr square by 2. Let's say the radius of gyration, let's say this is equivalent to, the moment of inertia is equivalent to a ring of the same mass m with radius k, mk square, okay, for that disk, okay, about z axis, right? So this is, let's say, mk1 here, okay. The radius of gyration of the uniform disk about the normal axis here, okay, normal is k1, let's say, and here we have this as the moment of inertia about any diameter. Let's say the radius of gyration is something k2, mk2 square, right? So from here I can say k1 is equal to square root of r square upon 2. From here I can say k2 is equal to square root of r square upon 4, right? The question is asking that what is the ratio of this one about the normal and about the diameter. That means you have to find k1 upon k2, right? So k1 upon k2 is square root r square by 2 divided by this thing. So this is going to be 4 upon r square. This becomes, this cancels out, and this is 2, right? So I'm getting k1 upon k2 is square root 2. That means the ratio k1 upon k2 is nothing but square root 2 is to 1. Okay, so this becomes the ratio square root 2 ratio 1. That becomes our answer for this question. Okay, thank you.